Okay, so on to fill this in. Now remember, um, you can use this set of data right here. Um, the only reason why we use 7 classes is because the textbook used 7 classes. And I'm trying to show you that the one that we do can be just like this one. So on this form right here, what is the class width for a frequency distribution with 7 classes? Now, be careful with this table because as we fill it in, if you don't use this top line for information, you'll only have room for 1, 2, 3, 4, 5, 6 classes. So you have to use this top line. So anyway, you fill in 7 classes right there. Think for just a second what's going to go right here. Okay, stop the video, pause it, and then think what should go right there. I'm about to show you. So for 7 classes, it wants the class width, so you use the formula, biggest number minus smallest number. So over there in that data, we go through all of these numbers, we find the biggest number and the smallest number, and 55 is the biggest, and I think these again were scores of Super Bowl. So one year somebody scored 55 points in the Super Bowl. The smallest number of points was 14. 55 minus 14 is 41. Divide it by 7 classes. And again, the only reason why we pick 7 classes is because we're trying to make it look like this histogram. And you come out to be 5.8. Remember, you always, always, always round up. So 6 is the class width. You've shown me your work. You've answered the question. So now it's time for you to go down here and start filling this in. Okay. So again, you should be thinking about what goes here, trying to fill this out. Just for time purposes, I already have one filled out. So I'm going to move this over. And we're going to look at the one that I already have done. We know, you should know that the smallest number, let me hide that, was 14. So the 14 is what we're going to put down first. Not going to worry about the end of that class. This is the beginning of the class. We're not going to worry about the end of it. We're going to figure out what the next beginning is. So 14 plus this 6, that means the next one should start at 20, the next one should start at 26, and all the way down. Okay? Now, if this second bin or second class starts at 20, when did the first one end? That's right, it ended at 19, and then you do 19 plus 6 and get 25, 31 plus 6, 37 plus 6, all the way down until you get to 55. You remember how we bumped those back? Take away a half, and remember why we did that? To bump those boundaries closer together. Then we did the tally marks. Now you should, take some time to do the tally marks yourself and see if they are similar to mine. I could be wrong. I mean, I did this in class one time. I saved it. Maybe it was last semester. I don't remember. But I could have made a mistake. So I end up with the frequency right here is 5, 12, 13. Either one of these could be wrong. So I could have miscounted. Down here, there's a total. The reason that I want to total these is to make sure I didn't miscount any of these. These should also total to be 51. Okay. So why is there 51? Because there were, in this data right here, there was 51 Super Bowls played. All right. Now this next one right here, let me move my sticker. Relative frequency, I haven't talked about that yet, so I'm going to define relative and cumulative frequency for you. Think about relative right here. Relative basically means, it means compared to what? Okay, so if you tell me the frequency right here is 5, if that's all I know, that the frequency is 5, is that a lot? Well, I have to know that this is 5 out of 51. Okay, so 5 out of 51. You tell me compared to what? The total. Okay, so relative frequency means you're telling me that there was 5 of them, but the number 5 all by itself, that I don't know if that's a lot of the outcomes or if that's just a few of the data points. Is 5 a lot of the data points, or is 5 just a few of the data points? I see this next category right here was 12, but still, if I'm dealing with 1,000 data points, 5 is really small, 12 is really small. But if I'm dealing with 20 data points, 5 is, a quarter of them, and 12 is a lot of 20. So you got to tell me, you got to think a relative is telling me, kind of, should I be impressed or not? So you make it a ratio, 5 out of 51, and then we normally convert that to a decimal, normally rounded to 1 decimal place. Now, here's the other thing that you need to, compared to what? Relative is equal to frequency over number in data set. Okay, so that's what relative frequency is. We normally round it to 1 decimal place. Relative frequency should always, the sum, this is the symbol that we're using for sum. This is epsilon, and this means sum. And so when I tell you to sum up the relative frequency, and it should equal 1. The sum of the relative frequencies should always equal 1. So if you're rounding right here and you're rounding, I did 2 decimal places right here because that would cause me to round up and that would cause me to put 0. So sometimes rounding to 1 decimal place doesn't work. If I add all these up and I get a number that's bigger than 1, then you have to go back and adjust your rounding, because the answer right here, relative frequency, always should be 1. Okay, now cumulative frequency, what does cumulative mean? Cumulative means that you are accumulating something. What is accumulating? It means you're saving, you're stacking up, you're getting more and more of it. So cumulative frequency, in this first bin right here, we had 5 numbers. Okay, 5 numbers were in the first bin, so we have 5 numbers right here. Then in the second bin we had 12. Well, cumulative frequency wants the total amount of the numbers accounted for in those first 2 bins. We had 5 numbers in the first bin, 12 numbers in the second bin. So after we add that second bin to the first one, we have a total frequency of 17. Then we do have 13 more. So we add 13 to that 17 and we get 30. Add 11 to 30 and we'll get 21. Add 5 to 41, we get 46. So this is the total of all the bins as we consider the next one. This number right here should always match this number right here. That's how you know you've done it right. Okay? So then on this one right here, this asks for a relative frequency histogram. I'm going to show you this in just a second. But right here, I took my class boundaries. I drew them along here. I did my frequency. The title of this whole thing right here would be called Super Bowl scores. What am I counting, or what am I looking at along the x-axis? These are Super Bowl scores. This is the frequency. So I know right here there were 5 Super Bowls that had scores between, we'd say, 14 and 19. Okay. Now, you again, don't forget, you could also label this with the midpoint. I don't really know what the midpoint of that is. I would add those 2 numbers together and divide by 2, and that would give me the midpoint. So you could take these boundaries off and label it with the midpoint. Okay. They could ask for another column up here and see what the midpoint was. So, and you could do the midpoint of this one or the midpoint of this one. It's going to be the same midpoint. So add 14 and 19 together and divide by 2. It's going to be like 16.5, I think, is the midpoint. Okay, so that's what the frequency looks like. If you did a relative frequency, then all that's going to change is these decimal numbers right here will be on the y-axis, and on the x-axis, everything else stays the same. So you look at the relative frequency, these numbers right here, and you put them on the y-axis. So instead of going all the way up to 13, because that was the biggest frequency in my bin, this bin right here, this third bin, had more of these numbers in it than any other bin. So it was the tallest thing right here. When you come over here and do relative frequency, that one right there is probably going to be the biggest decimal because it had the most numbers. So 13 out of 51, that 0.3 right there is showing that it's about 30% of all of the numbers. So notice that the shape is pretty much the same. The only difference is that this is not giving us actual numbers. It's just telling us in relation to its total, should we be impressed with this? And this is a lot. So 30% of the football games that have a score of something between 26 and 31. That means there's a good number of them that have that. So that's the most common score to have. Okay, and we would label this one football scores. We would just call this relative frequency, and this would still be called Super Bowl scores. Okay, so that is pretty much all of 2.1, all the 2.1 notes. You really need to be able to do any part of this. I am going to show you StatCrunch, how to do this on StatCrunch, and I can also show you maybe a few questions out of the book. So that's going to be on the next video.